Hi, students. So, welcome today to my channel. I'm going to be working out this Olympiad question, which seems scary, but it's actually simple. Scary because of the power 12. It's large. 12 is large. So, but I'm going to show you how to actually work it to simplify it. Okay, very simple. So, watch and learn. Solution now. You see, for you to do this, since it is a bit complicated because of the large power, what you need to do is to try and reduce it. Okay, how to reduce it? We start by substitution. So what we are going to do is let x be equals to 1 plus root of 5 all over 2. Okay, now once we say that, then it therefore means that this actually becomes x raised to power 12. Okay, so just watch and you are going to understand where I'm going towards. Now once you have this, why not let's cross multiply here, so that we are going to have 2x is equals to 1 plus root of 5. Now if we have this, then let's simplify it further by picking 1 to this side, so that I'm going to have 2x minus 1 is equals to root of 5. Since we have this, looks like something with sorts. So what can I do now? Why not let's square both sides? Square both sides, just to simplify it, taking away the square root aspect, okay? So if you square both sides, you are going to have 2x minus 1 all squared is equals to root of 5 all squared. And we know what happens. You see, this would go with this. So we are going to be left with expanding 2x minus 1 will be 4x squared, then minus 4x plus 1. I've expanded it. Then this is going to be equals to 5. Okay, rewriting it, we have 4x squared minus 4x, then plus 1. But once I decide to pick this 5 to come over here, it now becomes minus 5 is equals to 0. So this is 4x squared minus 4x, then minus 4 is equals to 0. Now you see all of them have the same coefficient, or they have a factor of 4. I can factorize 4 outside. Now once I factorize 4 outside, I'm going to, or just divide through by 4. Simply just do that, okay? Divide through by 4. You are going to be left with x squared minus x minus 1 is equals to 0. Okay. Now, the trick here is don't solve it, okay, quadratically. Instead, just have x squared is equals to, pick these two to the other side, okay, so that you are going to have x is equals to x plus 1. Now this is a very important expression that we're going to be using. X squared is equals to x plus 1. So take note of this. We are going to be using it, okay, to simplify our work. Now recall, okay, let me show you. Recall that we have x raised to power 12, okay, as our new expression. So since we have x raised to power 12, do you know that x raised to power 12 can actually be written as x raised to power 2 all raised to power 6? Yes, yes, yes. Why? Because of the law of indices that says x raised to power n all raised to power m is the same thing as x raised to power n times m, which is exactly what I've done here. Now again, recall that x squared is equals to x plus 1. Just look at it right above us. Okay, so instead of having x raised to power 2 all raised to power 6, I'm going to have x plus 1 all raised to power 6. Now, again, we are simplifying. Having x plus 1 all raised to power 6 from this, our indices law, do you know I can write this as x plus 1 all raised to power 2 all raised to power 3? Yes. And since we can do that, it therefore means that we have x plus 1 all squared all raised to power 3. Okay, now x plus 1 all squared, I can expand it. Now expanding it, I'm going to have x squared plus 2x plus 1. Of course, it's going to be all raised to power 3. Recall that x squared is equals to x plus 1. So I'm going to substitute x squared so that I'm going to have x squared instead. Okay, let me take this off. I'm going to have x plus 1 standing for this x squared now. Then I have plus 2x plus 1 all raised to power 3. Now adding it, I'm going to have 3x plus 2 all raised to power 3. You see, what I'm doing is at every point or all points, I just want to get x squared so that I can eliminate it. Okay, just reducing it. That is how I'll be simplifying it going down. Now, this can actually be written as 3x plus 2 all squared into 3x plus 2. Okay, and now this comes from that multiplication law under indices, where if you have x raised to power n times x raised to power m is going to be equals to x raised to power n plus m. Of course, this is like raised to power 1. So 1 plus 2 is 3. And that is the 3 we have here. Now, since we can do that, then we will now express, we have 3x plus 2 all squared into 3x plus 2. Now, this one can actually be expanded. So if I expand it, I'm going to have 9x squared plus 12x, then plus 4. This is what I have now. Then into 3x plus 2. Recall what we've been doing, just note that x squared is equals to x plus 1. You see, I have another x squared here that I can take out. So it now becomes 9 into x plus 1. Okay. Then remember, I have plus 12x, then plus 4. Okay. And this, we have 3x plus 2. Now, since I have this, once I expand, I'm going to have 9x plus 9 plus 12x plus 4. Good. Then I have 3x plus 2. Okay. Now 9x plus 12x, I have 21x. Then 9 plus 4, I have 13. Okay. Now into 3x plus 2. Now it is simple. I can now just expand. Now expanding 21x times 3x, that will give me 63x. Then 21x times 2, we have plus 42x. Then I have 13 times 3. Of course, I'm going to have 39x. Then plus 26. Okay, this is what I have now. But remember, this is squared. Okay, sorry for that. That is squared. Now, since it is squared, then I will now substitute. Okay, I'll substitute my x squared, which of course we know it to be what? X plus 1. Then I have plus 42x plus 39x, then plus 26. So that this is going to be 63x plus 63 then plus 42x, then plus 39x, then plus 26. Okay, you can see everything now has been expressed in terms of x and constants. Okay, so I don't have any ambiguity no more. So 63 plus, see, that is 63x plus 42x plus 39x, that will give me 144x. Then 63 plus 26 will give me plus 99. Now, watch this. Let's go back. Let me remind you of something. X is equals to, good, x is equals to 1 plus root 5 over 2. So I will now move back. Okay, we know that x is equals to 1 plus root of 5 over 2. So why not let me substitute it? Then I'm going to have 144 there into 1 plus root of 5 over 2. Okay, then plus 99. You can see that 2 here once and 2 here, we have 72. Okay, so I'm going to have 72 into 1 plus root of 5 plus 99. Now this will be 72 plus 72 root of 5, then plus 99. Of course, I can add 72 plus 99 to give us 171 plus 72 root 5. And this is the expansion. So this is the answer. Very simple. Now listen, some might say, okay, why not use binomial expansion theorem? Now that is a very good option too, but that should be ambiguous and vulnerable to mistakes. You can actually make mistakes, okay, because you're going to be dealing with a whole lot of numbers. So it is good you take this, okay? I want to believe you watched the video. I want to believe you stayed glued and enjoyed yourselves, okay? So please subscribe for more interesting math videos. Thank you so much.